In this video we're going to revise the ellipse. We're going to look at two methods for constructing an ellipse, the concentric circles method and the Trammel method. The first method that we're going to look at is the concentric circles. And in concentric circles, this is a very important construction, not only for how we set up an ellipse but also later on if we're given a point and we need to locate the major or the minor axis. So it has lots of ways that we can use this to solve other ellipse questions. So let's have a look at how we're going to set this up. I've put in a major axis here which is 110 millimeters, so the major axis is going to be the longest line in the ellipse. The minor axis then I've put in here as 60 millimeters, and our minor axis is the longest line perpendicular to the major axis, so it's halfway along the major axis. To draw this, I first need to create two circles, one with half the major axis as the radius. This will be the major auxiliary circle, and the second one then is going to be the minor auxiliary circle, so that's going to have half the minor as its radius. So that gives me two circles. I've got the major auxiliary circle and the minor auxiliary circle. Now we're going to use both of these to help us find our ellipse. So what I'm going to do is I'm going to divide my circle up with a 60-30 degree set square. You don't need to use 60-30. You can take any line that you like. So I'm just going to take a line down here just to show that you can do it at any angle that you like. So I'm going to divide it up to 60-30. So I'm going to take this line coming off up along here, and that is going to be one of my I'm going to use this line up here to find a point on the ellipse. Now what's really important and to remember and to understand is how we use this line. So this line is cutting the major auxiliary circle here, and it cuts the minor auxiliary circle here. So how we're going to use this, we're going to use those 2 points and the information that from whatever circle that line cuts. So the major auxiliary circle is cut here, so from this point we're going to go perpendicular to the major axis. So perpendicular to the major axis would be a line coming straight down along this way. So this is coming down along here, that's perpendicular to the major axis. That cuts the minor, that same line cuts the minor auxiliary circle at this point. So from there we're going to go perpendicular to the minor axis. So perpendicular to the minor axis, giving me a point on the curve there. If I do that again another time, so I'm using 30 degrees this time. So again, cuts the major auxiliary circle at this point, so we'll go perpendicular to the major axis here. It cuts the minor auxiliary circle at this point here, so bringing that out gives me another point on the curve. So same again, major auxiliary circle, perpendicular to the major axis, minor auxiliary circle, perpendicular to the minor axis, give me points there. This is the random line that I took a while ago, so that works the same way, perpendicular and perpendicular. Once you have a number of points found, the end of our minor axis is going to be 1 point, the end of the major axis is another point. You draw the best curve that you can that goes through all the points. And that gives us part of our ellipse. So that's one half of it. The other half of this is done the exact same way. So what I've done here is I've just set up another major axis and minor axis. This time the major axis is inclined at 30 degrees, the minor is at 60. This is like something that came up in the pre where the question was slightly skewed. So what I'm going to do here is I need to find my ellipse, and my construction is going to be the same. So again I need my major auxiliary circle, I need my minor auxiliary circle. And from here I need to find a number of points. So I've already got that point. I already have 4 points on the curve. Now I need to find a few more. So I can take lines at 60-30, or horizontal in this case. So I can take a line coming out along here, and another one going up along this way. So again, I need to follow the same principles as what I did in the previous question when the major axis was horizontal. My line, this one here coming out of it, intersects the major auxiliary circle at that point. So what I'm going to do is I'm going to do what I did a moment ago. I'm going to go perpendicular to the major axis from that point, cuts the major circle, perpendicular to the major axis. So this here is perpendicular. That same line intersects the minor auxiliary circle at this point, so I'm going to go perpendicular to the minor axis at that point. So perpendicular to that is here. I can do the same thing from this line here. This is my major, this is my line where it cuts the major auxiliary circle. So I'm going to go perpendicular to the major axis. This is my major axis. This is a line perpendicular to it. For this point, again, I've got it cuts the minor auxiliary circle. This is my minor axis. So line perpendicular to that comes out along this way. So I'm still plotting my points in the same way. I haven't changed anything, even though my axis is now at an angle. So the only thing that changes is the axis is at the angle. Everything else, you follow the same principles. So line cuts the major auxiliary circle, go perpendicular to the major axis. If it cuts the minor auxiliary circle, you go perpendicular to the minor axis. No matter what way you turn it, it's always going to be following that same principle. So that's our auxiliary circles method for drawing an ellipse. In this part of the video, we're now going to use the Trammel method to draw an ellipse. It's quite a handy method if you have if you're trying to avoid having too much construction in the middle of your ellipse where you might need to draw something else. There's a few disadvantages to this method though, in that especially if you're doing an exam, you end up ripping a sheet of paper, so you need to make sure you check with the superintendent first that that's okay, and you also need to tape your trammel to the page just to make sure that they know that that's how you drew it. Generally it's pretty clear that you used a trammel, but stick your trammel to your page just so that it's clear that this is what you did. So we have our major and minor axis again. So major axis is 110, minor axis this time is 70. So what we're going to do is, this is a trammel, sheet of paper, and all I'm going to do is mark a point A on the end of it. So that's my point A. So I'm going to put point A onto the end of the major axis, doesn't matter which end, and where the midpoint on the major axis is, so where the minor axis crosses, that's going to be point C. You can label them whatever you like. What I'm going to do now is I'm going to turn this 90 degrees so that A is now at the end of the minor axis. And where that crosses the major is the other point I'm looking for, and that's going to be point B. So the distance from A to C is half the major axis, and distance from A to B is half the minor axis. Now there's some great videos on YouTube about how these move if you just look up the trammel. So what essentially is going to happen, B is going to stay moving along this line here. C is going to stay moving along the minor axis as it rotates. And we're just, point A then is plotting the ellipse. So to do this, point B is on the major, C is on the minor, make sure it's lined up, and just put a dot at A. Continue doing that, moving around. So B is staying on the major, C staying on the minor, moving my points around. Keep moving this around, plotting, and there we have a number of points forming one quadrant of the ellipse. Can keep going with this, so B keeps moving over and back across the major axis, C on the minor. So keep plotting your points as it moves around. Now underneath, when it twists underneath, some people seem to get a bit confused by this. All that happens is C continues moving up along the minor axis. C keeps now moving back the opposite direction on the major axis. And we'll keep plotting our points as we're going along. So as you can see, there's no construction really in the middle of this. So if you had to draw something for your question, it minimizes the amount of lines that you have in the middle of the page, which might make it a little bit confusing for you. So there we have our basic shape, all plotted with dots. Now we just need to draw our best curve that we can. It touches all of those points. So the more points that you have on this, the more accurate it's going to be. And there we have our ellipse. Just a quick reminder again on how you set this up. The distance from A to C is equal to half the major axis. Distance from A to B is half the minor axis. So A always goes at the outside, it's on the end of the major and the end of the minor when we're measuring. And our points are going to rotate, move around. B stays moving across the major, C across the minor.